Equations with variables on both sides. Definitions. Identity is an equation that is true for every value of a variable. So no matter what number you put in for that variable, the statement or the equation will be true. VIC number 1 states that an equation has no solution if no value of the variable will make an equation true. So for example, 2x equals 2x plus 1. If we were to solve this, so we're going to subtract 2x on both sides. Well, 2x minus 2x gives me 0, and 0 does not equal 1. That statement is not true, therefore it is no solution. Now remember, just like in multi-step equations, we have certain steps we need to follow. For equations with variables on both sides, you always first distribute, just like in multi-step equations. Get rid of those parentheses. Then clear your equation of fractions. Remember, that's optional, but if you aren't very good with fractions, it's a good idea. Step 3, get the variable on one side of the equal sign and numbers on the other, just like in multi-step equations. We want all of our variables on one side, our numbers on the other. And the last one is get the variable by itself. You do that by using our steps from two-step equations. You add and subtract first, and then multiply and divide. So let's do some practice problems. Number 1, 6x minus 2 equals x plus 3. As you can see, we have variables on both sides. Our first step is to distribute. We do not need to distribute because we do not have parentheses anywhere in the equation. So now, I don't have any fractions, so I don't have to clear those out. Now I want to get all the variables on one side. I like my variables on the left, but you can also have them on the right. It does not matter, as long as they're all on one side. So for me, remember this is the same thing as a 1x. So I'm going to subtract x on both sides, because if you do it on one side, you must do it on the other. So now I'm left with 5x minus 2 equals a 13. Now we just follow the rules from two-step equations. Add and subtract, and then multiply and divide. Here it's minus 2, so I'm going to add 2 on both sides. I get 5x equals 15. This is multiplication. The inverse operation of multiplication is division. So we're going to divide by 5 on both sides. 15 divided by 5 is 3, so our answer is x equals 3. If we were to check this, we plug it back in for this x and this x, and then solve and see if both sides of the equation are equal. Number 2, 8 minus x equals 2x minus 1. Step 1 is to distribute. We do not have any parentheses, so we can skip that step. Step 2, which is optional, to clear out our fractions. We do not have any fractions to clear out. So now we're on to step 3, which is to get all the variables on one side and our numbers on the other. So here I'm going to subtract 2x from both sides. Well, this is the same thing as minus 1x. Remember, subtracting is the same thing as adding a negative. So I can say this as plus a negative. Negative 1 minus 2 gives me a negative 3. And then I just bring down the 8. So now I have 8 minus a negative 3 equals a negative 1. Remember, that sign goes with it. It does not disappear. Now I want to move my 8 to start getting my variable by itself. Well, 8, it's a positive 8, so I'm going to subtract 8 from both sides. I'm left with a negative 3x equals a negative 9. Divide by negative 3 because negative 3 times x is multiplication, and the inverse operation of multiplication is division. So we're going to divide by negative 3 on both sides. Well, negative 9 divided by negative 3 is a positive 3 because a negative divided by a negative is a positive. So our answer is x equals 3. Number 3, 2n minus 5 equals 8n plus 7. Like 1 and 2, we do not have any parentheses, so therefore we do not have to distribute. We don't have any fractions as well, so we don't have to worry about those. So now I'm going to get variables on one side and our numbers on the other. This time I decided to put the n or the variables on the right hand side. Either way, remember, it does not matter as long as they're all on one side together. So here I subtracted 2n from both sides. I'm left with a negative 5, so I just bring that down. 8 minus 2n is 6n, and then I bring down the rest, which was a plus 7. My whole goal is to get n completely by itself. You are going to add it or subtract first. Since this is addition, I'm going to subtract 7 on both sides. Negative 5 minus 7, remember, you do keep, change, change. So it's a negative 12 equals 6n. 6 times n, so I'm going to divide on both sides to get n completely by itself and positive. So I divide by 6 on both sides, and I get negative 2 equals n for my answer. Now, number 4 is a little different than the first 3 that we did. Still no parentheses, so we don't have to distribute. We still don't have any fractions, so we don't have to worry about those. But if you see 4p minus 10 equals 1p plus 3p minus 2p. If you remember from multi-step equations, you need to combine like terms on both sides before you start moving them around. Well, we do not have any like terms on the 4p minus 10 side, but we do have like terms right here. They all have the same variable p. So 1p plus 3p is 4p. Minus 2p gives me a total of 2p on the right-hand side of the equal sign. Now, I have 4p minus 10 equals 2p. Well, on this side, the variable is already getting by itself. So there's no need to put it to the left. We'll just bring all the other ones to it. So we're going to subtract 4p on both sides. I'm left with a negative 10, so I bring that down, and 2 minus 4 gives me a negative 2p. I've got one more step before I can get the variable completely by itself. This is multiplication. The inverse operation of multiplication is division. So I'm going to divide by negative 2 on both sides. These cancel. Negative 10 divided by negative 2 is a positive 5, because a negative divided by a negative is a positive. Now let's look at number 5. This one does have parentheses, so we must distribute first. And remember, the distributive property, that means we are going to multiply 4 by every term inside the parentheses. So we rewrite 6x equals 4 times x gives me 4x, and 4 times 5 gives me a plus 20. Make sure that you are multiplying every term inside the parentheses. Now, I don't have any fractions, so I don't have to worry about getting rid of those. So now I want to give all my variables on one side. Well, there's just variables on this side already, so I'm going to move the 4x to the left. It's a positive 4x, so I'm going to subtract 4x. If I do it on one side, I must do it on the other. 6x minus 4x is 2x. These cancel, and I'm left with 20. This is multiplication, so the inverse operation of multiplication is division. So I'm going to divide by 2 on both sides. So my final answer is x equals 10. Now, if you remember, one of the definitions at the beginning of this video was the identity, when every value for the variable makes the equation true. So here, we're going to solve these equations and determine if it's an identity or a no solution. So number 1, we have 18x minus 5 equals 3 times the quantity 6x minus 2. We have parentheses, so our first step is to distribute. So I said 3 times 6x, I get 18x, and 3 times 2, I get a minus 6. Now I want to get all my variables on one side, so I subtract 18x on both sides. Well, 18 minus 18 gives me 0, which means that x went away. Now I'm just left with 0 minus 5 equals a negative 6. Well, 0 minus 5 is a negative 5, and negative 5 does not equal a negative 6. The statement is not true, so therefore it is a no solution. If the statement is not true, then we cannot have a solution that is possible. Number 2, Number 2, we do not have any parentheses. We just have 9 plus 5a equals 2a plus 9. I'm going to get all my variables on one side. So I subtracted 2a on both sides. 5 minus 2a is 3a, and I bring down the 9. So now we always add and subtract before we multiply and divide. So it's a positive 9, so I subtract 9 on both sides. So 9 minus 9 gives me 0. I'm left with 3a on the other side. I divide by 3. 0 divided by any number is always going to be 0. So 0 divided by 3, so a is going to represent 0, or be equal to 0. Number 3, we have a minus 4a equals 2a plus 1 minus 5a. We do not have any parentheses, so we will not distribute. We have no fractions, so we don't have to worry about getting rid of those. We do need to see if we have like terms on either side of our equal sign. So I cover up the right-hand side. A minus 4a, well, these are like terms. Remember, this is the same thing as 1a. So then 1a minus 4a gives me a negative 3a. Now I'm going to look to the right. I have 2a and a minus 5a. Those are like terms. They both have the same variable a. So 2 minus 5 is also a negative 3a, and then we add the 1. I want to get all my variables on one side, so I add 3a to both sides. Well, negative 3 plus positive 3 gives me 0, and I'm left with 1 on the right-hand side. Well, 0 does not equal 1, so therefore we have another no solution. And number 4, we have 14 minus the quantity 2q plus 5 equals a negative q plus 9. I rewrote this with the 1 in front because remember, anytime you're minus and then up against a parentheses, it's the same thing as minus 1 times that quantity. So we are going to have to distribute. So we have 14 minus, and this whole thing is going to be distributed. Negative 1 times 2 gives me a negative 2. Negative 1 times 5 gives me a negative 5. Equals 2q plus 9. Now we want to check for, do we have any like terms on each side of the equal sign? So I cover up the right. I have 14 and minus 5, or a negative 5. These are like terms because they're just numbers. They don't have a variable with it. So 14 minus 5 gives me 9. And then I bring down the 2q. So we have 9 minus 2q equals, now we look on this side. Negative 2q and 9 are not like terms, so we just rewrite it. Now I'm going to get all my variables on one side. So this is a negative 2, so I add 2q on both sides. Well, negative 2 plus a positive 2 gives me 0, so I'm just left with 9 on both sides. 9 equals 9. That is an identity. It is a true statement, so this is an identity equation. All right, let's do some practice problems with me. Here we have 2 times the quantity 4x minus 2 equals a negative 2 times the quantity x plus 5. Step 1 is to distribute. So I'm going to say 2 times 4 and 2 times 2. 2 times 4 is 8 minus 2 times 2 is 4x. I also have to distribute on the other side because there's parentheses on the right as well. Negative 2 times x is a negative 2x. And negative 2 times 5 is a minus 10. Now, I do not have any fractions. I don't have like terms on either side that I have to combine first. So now I'm going to get the variable all on one side and numbers on the other. And this is a minus 2x, so I'm going to add 2x to both sides. I'm left with 8 minus 2x equals a negative 10. I want to add and subtract first before I multiply and divide. So this is a positive 8, so I'm going to subtract 8. I'm left with a negative 2x equals, if I do keep change here, I get a negative 18. Divide by negative 2, because that's multiplication, and the opposite or the inverse operation is division. These cancel, and I'm left with x equals 9 as my answer. All right, number 2. We do not have any parentheses, but we have 7/8 W equals 4/8 W plus 6/8 W. We do have fractions. I don't like fractions, so I'm going to get rid of them first. They all have the same denominator, so I can multiply this whole equation by 8, therefore canceling out my denominator. And I'm just left with 7W equals 4W plus 6W. This is a whole lot easier to work with. Now I'm going to combine like terms on each side of the equal sign. So I have 7W equals 10W. Now I'm going to get all of my variables on one side. If I subtract 7W, well, 7 minus 7 leaves me with just 0 equals 3W. If I divide by 3, 0 divided by 3 is just 0. So W equals 0. Number 3, I do not have any parentheses. I do not have fractions. But I do need to combine like terms. This side, there are no terms, so just no terms that are common or like terms, so we just write 0. Now, 9800ths B plus 200ths B, that gives me 1B, and then we're minusing B. Well, 1B minus B, this is the same thing as minus 1B. Well, 1 minus 1 is 0, so 0 equals 0. This statement is true because you have the exact same on both sides of the equation. So this is an identity. Number 4, we have 1/2 y plus 2 equals 8/10 y minus 3/10 y. We do not have parentheses, so we don't have to distribute. We don't have fractions, so we're not dealing with those. We need to combine like terms. We look to the left, we don't have any. We do have some to the right, so I'm going to rewrite the left. Then 8/10 minus 3/10 leaves me with 5/10. I want to get my variable on both sides, so I'm going to subtract 5/10. I'm left with 2 equals 0. Does 2 equal 0? No, that is not a true statement. They are not equal, so it is a no solution.